Welcome to RAT Shikshan Sanstha Satara's RAT Online School Education Project. So, we have already started studying the topic laws of motion, and today we shall discuss the impulse of a force, necessity of defining impulse, moment of a force, torque, couple, and we'll also prove that moment of couple is independent of axis of rotation. We shall now discuss what is impulse of force. The change of momentum of an object when the object is acted upon by force for a given time interval is impulse. What we know is, according to Newton's second law of motion, F is equal to dp by dt, right? Force is rate of change of momentum, this expression that we know. So now see, so if this dt is taken to left side, multiplication with f into dt will be dp. This f into dt, that is force into time, is the impulse of the force. It is impulse. F into dt is impulse. It is given a new symbol j. So j is equal to f into force into time is equal to dp, that is change in momentum, is p2 minus p1. So j is p2 minus p1 is change in momentum is equal to mv2 minus mv1 is equal to force into time. If force is not constant and it is a varying quantity, then j can be found out by integration of this quantity f into dt. See, this is the graph of an impulse of a force. I mean, force into time. Force versus time graph is plotted, and area under this curve, it gives you the j, that is force into time. Why we define impulse of a force actually? See, j is equal to dp is equal to p2 minus p1 is equal to f into time. We know that force into time, it gives you the physical quantity j, that is impulse. Sometimes force acts for extremely small interval of time. See, if t is very small, it is not measurable. Then, but change in momentum is measurable one. And it is change in momentum is noticeable and can be measured. That time we have to such a situations are hitting of a ball with bat, giving a kick to a football, hammering a nail, bouncing a ball from a hard surface. Here, see, in this case, time for which the force acts is very small. म्हणजे जेव्हा आपण एखाद्या बॅट ने बॉलला मारतो किंवा फुटबॉलला एखादी किक देतो, खिळ्यावर हातोडा मारतो, तेव्हा या सगळ्या केसमध्ये टाइम इज व्हेरी स्मॉल, but the change in momentum is measurable quantity and can be it is noticeable and measurable. So that is why it is necessary to define an impulse. We shall now study rotational analog of a force, that is moment of force or torque. Till now we have studied translational motion. We have not studied rotational motion. आजवर फक्त translational म्हणजे motion along straight line study केली आहे, rotation नाही. किंवा rotational motion अशी काही वेगळी असते किंवा त्याला काही वेगळी separate treatment दिली पाहिजे वगैरे असं काही आजवर study केलेलं नाही. But now we are going to do it. See. The question is, what is which physical quantity is responsible for rotation? म्हणजे समजा आपल्याकडे एखादा body आहे which is stationary, which is not in motion. So what we do is we apply a force to set it in motion. बरोबर आहे? So and we say force is responsible for the motion of the body. तसं what is now the question is, what is required for body to set into rotation? Is it a force or is it something different? That we have to see. We shall see example now. इथे एक दरवाजा दाखवलाय आणि we have to turn it. रोटेशनल इफेक्ट आहे. तर दरवाजा आपण उडतो बंद करतो, हा रोटेशनल इफेक्ट आहे. सो रोटेशनल इफेक्ट साठी आपल्याला काय गरजेचं आहे बघा. वी नीड टू अप्लाय अ फोर्स फर्स्ट ऑफ ऑल. आपण दिस इज अ डोअर and these are the hinges, म्हणजे आपल्या बिजागऱ्या. So to have a turning effect, what we do is we'll use this handle. इथे मी 3 हँडल दाखवले. So first of all आपण हे जे नेहमीचे जे हँडल आहे हे आपण बघूया. So first of all, to have the rotational effect, we have to apply a force. Without application of force, will not get rotational effect. So magnitude of force is of course important. म्हणजे ह्याला धरून आपण ओढणार. So इथे धरून ओढलं ही फर्स्ट what to say handle. So which we usually do. आपल्याला सोपं जातं. समजा हे दुसरं हँडल आपण वापरलं, which is nearer to the axis of rotation. This is axis of rotation. Which is nearer to the axis of rotation. What do we find out? थोडं डिफिकल्ट जातं. इथे हँडल असणं योग्य नाही वाटत, इथेच वाटतं. इथे असलेलं लांब असलेलं हँडल धरून ओढणं सोपं वाटतं. If the handle is very near to the axis of rotation, then we find it difficult to rotate the door, pull the door. दरवाजा ओढणं आणि उघडणं बंद करणं आपल्याला इथे जर हँडल असेल तर अगदीच अवघड पडेल. So what is it that is responsible for, that is giving you rotation? Of course, force is there. Force we have to apply. At the same time, distance from the axis of rotation. This distance from the axis of rotation is important when we see the turning effect of the force. The distance from the axis of rotation म्हणजे कुठलं घ्यायचं आहे? हे ते distance नाही ना घेणार आपण. हे no. So this distance we are going to have. So obviously then it is perpendicular distance from axis of rotation. This so we can put it into one formula. So rotation ability of a force to produce rotation is called moment of a force. I repeat, ability of a force to produce rotation is called moment of a force, and moment of a force it will have in that is equal to product of force that we apply multiplied by perpendicular distance from axis of rotation. Here the distance. So this is put into one formula. So magnitude of moment of force, one more term is there, torque, is equal to magnitude of force multiplied by perpendicular distance from axis of rotation. Hey, hello. This is what it will contribute to rotational effect of a force. म्हणजे आपल्याला एखाद्या फोर्सचा फोर्स प्रोड्यूस केला रोटेट बॉडी कशामुळे होते तर मोमेंट ऑफ फोर्स किंवा टॉर्क मुळे होते. दोन गोष्टी त्यात कॉन्ट्रीब्यूट करतात, मॅग्निट्यूड ऑफ फोर्स अँड परपेंडिक्युलर डिस्टन्स फ्रॉम द ऍक्सिस ऑफ रोटेशन. सो दिस वी आर गोइंग टू पुट इनटू वन फॉर्म्युला. सी इट इज what is written is moment of a force or torque tau is equal to r cross f. This is actually, what we have seen is we have seen the magnitude of moment of force is magnitude of force multiplied by perpendicular distance from axis of rotation. But this rotation is a vector quantity because we can have clockwise rotation, anti-clockwise rotation. It refers to some direction. So there will be some formula which will be a vector, which will have vector quantities. So this is what is this formula, magnitude of moment of force. This formula and this formula both are same. But why are we using this tau is equal to r cross f that we are going to see. But at present, let me define a rotational analog of a force is the moment of force or torque, and it is defined as r cross f, where this f is going to take care of the force, applied force, and r cross f. What we have seen is the distance from axis of rotation is important. So that r cross f gives you the torque or moment of a force, which is a rotational analog of a force. So whenever we are going to talk about rotation, we'll talk about torque. Responsible quantity for rotation is torque. So tau is equal to r cross f. This we'll see more about this formula now. See, here we can see an object. this is the body, this is the axis of rotation, and body can move in clockwise direction or anti-clockwise direction. As again, here it is, this is just to show you the axis of rotation. Now see, this is the body. See, this is the direction in which force is applied. See, this is the direction in which force is applied. So this is the direction of application of force. And this is the point of application of force. This is the point of application of force. So R, that is position vector. See, if this is the point through which axis of rotation passes, this will be R. From axis of rotation to the point of application of force, this will be R, and this is the direction of application of force, this. And R cross F is going to be, this is force multiplied by this is R. R cross F is going to be, I shall do it with this. It will be this perpendicular distance multiplied by this force. Magnitude of force multiplied by perpendicular distance. So R cross F, it will be the top. Now one can see here what is something shown, that round and once again dot. That is going to give me the direction of rotation. R cross F is a vector quantity, and the direction will be depending upon whether the body is going to move clockwise or anti-clockwise. That will decide the direction of R cross F. So, see, this is the direction of force of application, and this is R. If we observe this force will, after application, will rotate the body in anti-clockwise sense. And so tau is equal to R cross F will be towards us, that is perpendicular to the plane of rotation, facing towards us, and the body will move in anti-clockwise rotation. So when it faces towards us in the outward direction, we show it using dot. This is dot notation. See, this is cross notation. When it is cross notation, after application of force, see, if this force is applied, R cross F is equal to tau, what will be the direction of rotation? If this way force is applied, the body will move in clockwise direction. When the body moves in clockwise direction, R cross F will face inwards and tau will face inwards. So there is shown a cross notation. Dot notation shows that the tau is facing in the outward direction and the motion is anti-clockwise. Cross notation shows that the motion is clockwise sense, rotation is in clockwise sense, and torque is acting in inward direction. Now we shall see what is couple. प्रत्येक वेळी रोटेशन साठी एकच फोर्स अप्लाइड असेल असं नाहीये. See, we shall see some examples. See, here there is an example of a turning of a bicycle handle. तर हा बायसिकल वर बसलेला माणूस आहे. तो कसा जर त्याला वळवायचंय तर तो कसं वळवतो, हे इकडून ओढतो आणि I shall use this word. हँडल वळवायचं असेल तर हा हात इकडे घेईल आणि हा हात इकडे घेईल, म्हणजे दोन फोर्स अप्लाय होतील, एक इकडून आणि बऱ्यापैकी इक्वल आणि अपोजिट असतील, इक्वल पण अपोजिट डायरेक्शन. सो दुसरं एक्झाम्पल घेऊया. दुसरं एक्झाम्पल आहे टर्निंग ऑफ स्टिअरिंग व्हील. सी, हा हात आहे, it will move in this direction. इकडून या दिशेने फोर्स अप्लाय करणार, इकडून या दिशेने फोर्स अप्लाय करणार. We are using two equal and opposite forces, but the lines of action do not match. एक या दिशेने आहे, एक या दिशेने आहे, पण लाइन्स ऑफ ऍक्शन्स मध्ये डिफरन्स आहे, दे आर डिफरंट. तिसरं एक्झाम्पल आहे यूज ओपनिंग अ कॉमन वॉटर टॅप. देअर ऑल्सो एक इकडून फोर्स अप्लाय होतो, एक इकडून होतो. दोन इक्वल अँड अपोजिट फोर्सेस, but their lines of action do not match. Same thing here, opening the lid of a bottle. बघा कसा फोर्स अप्लाय झालाय, एक इकडून आणि एक तिकडून, या बाजूने एक आणि बुचाच्या त्या पाठीमागच्या बाजूने एक, त्या बाजूला उलट्या बाजूला. So we are using two equal and opposite forces which are responsible for rotation. Now the two equal and opposite forces, पण त्यांचे लाइन्स ऑफ ऍक्शन सेम नाही आहेत, वेगळे आहेत. डिरेक्शन फोर्स लाइन्स ऑफ ऍक्शन ऑफ फोर्स आर डिफरंट. सो सच टू इक्वल अँड अपोजिट फोर्सेस form a couple. We shall see the definition of couple. A pair of forces consisting of two forces of equal magnitude acting in opposite directions along different lines of action is called couple. See, what we have noticed is it will produce purely rotational motion. And moment of couple or rotating effect of a couple is also called a torque. We need to find out the magnitude of the torque that we shall see now. I repeat, moment of couple or rotational effect of couple is also called torque. We have seen tau is equal to R cross F. So tau is equal to R into F into sine theta. And depending upon the value of sine theta, the value of torque will vary. And so if theta is equal to 90 degree, tau will be R into F because sine 90 is 1. And if theta is equal to 0, then torque will be equal to 0 because sine 0 is 0. अजून एक गोष्ट, important गोष्ट आपल्याला अशी बघायची आहे, that we are going to see now, that if there is a couple acting on the body, that is there are two equal and opposite forces, the magnitude of moment of force or couple, moment of force or torque is independent of axis of rotation or point of application of forces. I repeat, this, if there is a couple acting on the body, that is two equal and opposite forces, then the torque is not going to depend upon position of axis of rotation or point of application of force, that we shall see now. We shall now learn more about moment of a couple or this. See, this is the force F1. See the line of action of force F1. This is the line of action of force F2. F1 and F2 are two equal and opposite forces. So they form a couple. Now, समजा इथे असता आपला काय असता आपला axis of rotation असता. So हा मगाशी जसं शिकल्याप्रमाणे आपण R cross F कसं दाखवलं असतं. This would have been the position vector R, and this would have been the force F1. So R cross F, F1, a notation R12. It's the current because this axis of rotation lies now on this line of action of force F2, and this is the position vector for force F1. The angle between them is alpha, R position vector and force F1. So this R12 multiplied by F1 will give you torque tau 12. Torque. And suppose the line of this is the direction of force F2. समजा इथे axis of rotation असतात. What we would have done is, this would have been the position vector R21 for the force F2 and R21 cross F2. We would have got the magnitude of the force. Now, basically, if I find out R cross F for the first case, it is going to be this perpendicular distance R multiplied by magnitude of force F1. If I find out R21 cross F2, again that will be this perpendicular distance R multiplied by F2. Now so this will be R into F in both cases. It will be R into F. म्हणजे ऍक्सिस ऑफ रोटेशन कुठेही घेतला, एकदा इकडे घेतला होता, एकदा इकडे घेतला होता. So torque or moment of couple, it was independent of the axis of rotation, position of axis of rotation. This we are talking about when we are applying a couple. जर couple apply केला असेल तर moment of given couple is constant and it is independent of the points of application of forces or the position of axis of rotation. हे आपण couple बद्दल बोलतोय, single force बद्दल नाही. Now we shall see the difference between moment of a force and moment of a couple. म्हणजे एक सिंगल फोर्स जर बॉडीवर ऍक्ट होत असेल तर काय आपलं काय होईल, आणि जर कपल म्हणजे टू इक्वल अँड अपोजिट फोर्सेस लाईन्स ऑफ ऍक्शन डू नॉट मॅच जर ऍक्ट होत असेल तर काय होईल हे आपल्याला बघायचंय. सिंगल फोर्स जेव्हा ऍक्ट होतो तेव्हा दॅट टाउ दॅट इज आर क्रॉस एफ दॅट डिपेंड्स अपॉन पोझिशन ऑफ ऍक्सिस ऑफ रोटेशन अँड पॉइंट ऑफ ऍप्लिकेशन ऑफ फोर्स. तिथे टाउ डिपेंडेंट असतो म्हणजे टॉर्क. पण इथे इन केस टू कपल ऍक्ट्स, torque does not depend upon the axis of position of axis of rotation or point of application of force. They depend asat nahi. Moment of a force, the single force act of the cell, but it can produce translational acceleration also if the axis of rotation is not fixed or if friction is not enough. But moment of a couple act of the cell, it will produce purely rotational motion. It will not produce any translational acceleration in the body. So, and that is why if a single force is acting on a body, its rotational effect can be balanced by a proper single force or a proper single force. And here if a moment of couple is acting on the body, इथे couple सुद्धा चालेल rotation stop करायला. And if rotational effect of a couple, if it is acting, it will be balanced only by equal and opposite couple. सिंगल फोर्सला रोटेशन स्टॉप करायला सिंगल फोर्स किंवा कपल सुद्धा चालेल, पण कपलने प्रोड्यूस केलेलं रोटेशन स्टॉप करायला यू नीड इक्वल अँड अपोजिट कपल ओनली. Now we shall prove that moment of couple is independent of axis of rotation. See, this is a plain lamina or rectangular sheet one can have. There are two forces acting on it. See, this is this is first force and this is second force acting on the plain lamina. These two are equal and opposite forces, so they form a couple, and their lines of actions are different, so they form a couple. This is the what is shown is the axis of position of axis of rotation. Actually, the position of axis of rotation can lie on this line anywhere. So it is shown here now at present. This is the position of axis of rotation. For this particular force x, this is distance x, which is perpendicular distance from axis of rotation, and if this is the line of action of this force, this is the perpendicular distance from axis of rotation for this force. This distance is x, this distance is y, and this is r, perpendicular distance between two equal and opposite forces. Now see, if simply this force is acting and this is the axis of rotation, what it will do, it will rotate the body in anti-clockwise sense. If this force is not there, and if this force is acting, this is the axis of rotation, even this force will move the body, will make the body rotate in anti-clockwise sense. So both the forces make the body rotate in anti-clockwise sense. So we'll consider both positive. See. So this is O. Now this torque, this is the total torque acting on the body. It is tau plus and tau minus. That is torque due to this force, which is in this direction, left side, and torque due to say minus F, which is exactly in opposite direction. But both produce rotation in anticlockwise sense. So now torque due to first force, this force is magnitude of force multiplied by perpendicular distance, that is x into F, plus due to this force, it is magnitude of force into perpendicular distance, so it is y into F. So x into F plus y into F will give me x plus y into F, and one can observe x plus y is equal to r, that is r into F. That is, moment of couple here is magnitude of force multiplied by perpendicular distance between two forces. Okay, so see here there is no in the formula we don't refer to the position of axis of rotation. It is simply magnitude of force multiplied by perpendicular distance between axis of rotation between two forces. That is, this couple is independent of position of axis of rotation. This is proved. हे आता आपण कशासाठी बघितलं, जेव्हा axis of rotation it was lying between two lines of actions of the two forces. हा फोर्स लेफ्ट साइड आहे दिसतोय, हा फोर्स इथं दिसतोय. या दोन फोर्सच्या लाईन्स ऑफ ऍक्शनच्या मध्ये आपण काय घेतलंय, पोझिशन ऑफ ऍक्सिस ऑफ रोटेशन घेतली. आता दुसरी केस घेऊया, वेअर इन सी दिस ऍक्सिस ऑफ रोटेशन इज हियर, म्हणजे हा एक फोर्स झाला, हा फोर्स झाला पहिला फोर्स, हा दुसरा इक्वल अँड अपोजिट फोर्स, यांच्या लाईन ऑफ ऍक्शन मधलं डिस्टन्स आहे आर, आणि ऍक्सिस ऑफ रोटेशन हे या बाजूला आहे, एका दोन फोर्सेसच्या एका बाजूला, मध्ये नाहीये, मगाशी मध्ये होता, आता या बाजूला आहे. सो विल सी द रोल्स ऑफ द टू फोर्सेस. This force acting on this plane lamina will rotate the body in the anticlockwise sense. This force acting on the body, see, this is plane lamina, it will make it rotate in clockwise sense. So हा force जो टॉर्क प्रोड्यूस करतोय त्यामुळे बॉडी अँटीक्लॉकवाइज सेन्स मध्ये मूव्ह होतीये, आणि हा फोर्स बॉडीवर ऍक्ट होतोय त्याच्यामुळे बॉडी क्लॉकवाइज सेन्स मध्ये मूव्ह होतीये, आणि त्याच्यामुळे दोन्ही आपल्याला टोटल टॉर्क काढताना एक या फोर्स मुळेचा जो टाऊ प्लस आहे त्याच्यातून या फोर्स मुळेचा जो टाऊ मायनस आहे ते सबट्रॅक्ट करायला लागते. सो आता we will find out the magnitude of this torque due to this force. The torque is magnitude of force multiplied by perpendicular distance from axis of rotation. So magnitude of force is F, perpendicular distance from axis of rotation is Q. So Q into F. याने झालं अँटीक्लॉकवाइज टॉर्क, म्हणून हे पॉझिटिव्ह लिहिलंय टॉर्क. अरे या फोर्स मुळे होणारा टॉर्क म्हणजे मॅग्निट्यूड ऑफ फोर्स मल्टिप्लाइड बाय परपेंडिक्युलर डिस्टन्स. सो एफ इंटू ऍक्सिस ऑफ रोटेशन हा आहे, त्याच्यापासूनचं परपेंडिक्युलर डिस्टन्स आलं पी. सो दॅट इज वाय पी इंटू एफ. बट दिस फोर्स इज प्रोड्यूसिंग रोटेशन इन clockwise sense, and that is why it is minus pf. So what we get is q minus p into f. F is common. What we observe is this q minus p gives us r. So it is again r cross r into f, where so total torque acting on the body due to couple is magnitude of one of the force f multiplied by r, that is this perpendicular distance between two forces. This is first force, the second force, perpendicular distance between the forces is r. See, again we observe that the moment of couple is independent of axis of rotation. Torque जेव्हा बॉडीवर कपल ऍक्ट होतं, म्हणजे दोन इक्वल आणि अपोजिट फोर्सेस, तेव्हा टॉर्कचं मॅग्निट्यूड इट इज इंडिपेंडेंट ऑफ पोझिशन ऑफ ऍक्सिस ऑफ रोटेशन. That's it. Okay.